Everyone, come on. Yesterday, that one was giving me some trouble. That screen was. Quick announcement. I think it's every other year we do the Women in Data conference in the Twin Cities. So the Women in AI and Data Science Conference now is November 4th in the Twin Cities. It's co-production between the University of Minnesota and Mini Analytics. Mini Analytics is a well-known organization in recent years. We have a little version of it up in Duluth, but there's a much larger version in the Twin Cities, and they have a huge data conference in June each year and stuff like that. Do a lot of neat stuff. They have a lot of corporate sponsors in the Twin Cities, companies that want to hire or get data science people or build a better data science community down in the Twin Cities there. So in the fall, they have Women in AI and Data Science Conference. It's a free event, one-day event. You can go to it. You can attend it either in person or virtually. I'm signed up to go down there in person, and if you want to share a ride or whatever, I'm planning for these things. I just go down or leave in the morning and come back in the evening. So make it a one-day event, so I only lose one day of school and classes and that sort of stuff. So I'm planning on going there in person. I'm somewhat selfish reasons. My daughter is a woman in data science person down in Twin Cities, so she will be attending this event. So I'm going down. It's a great event. I've been to this event before, but I also like to have lunch with my daughter at this event also. So if you want to join me there, you can certainly join. And again, you can attend either virtually. It's just a Eventbrite? What is Eventbrite registration. Just quick, get your free tickets and that sort of stuff. For that. It is I believe all women presenters and stuff like that. You don't have to necessarily be a woman to attend there. I'm attending. But again, just realize it is focused on women in data science and women presenters, this particular one. And I think, like I said, I think they run this every other year, and I forget what they have another conference that runs on the odd years for this. So I'm going to check on a van for the college. So if we want to just drive a vehicle down, I'll check on that and let you know. Okay, what are we doing this week? So it's week 5, that means unit 5 here, and we'll be talking about interfaces and patterns. Let me pop up the textbook here. So again, we did the agile stuff. Now we're starting this foundation stuff. We'll be doing this. There are 5 units in this. We'll do this basically the first half of the semester, and then the second half we cover what are called the solid patterns. These are 5 patterns that form the acronym SOLID. And so we spend a unit on each one of these patterns later on in this. But we're not here, we're just getting kind of laying the groundwork so we can understand those patterns better and look at some generic patterns, other patterns that aren't solid patterns here. Apparently because they do not have the right letter for the acronym. So we talked about dependencies and layering and like model view controller type layering last week. This week, we're going to get into interfaces and our first design patterns we'll be covering. So that's what we're doing. Normal discussions this week. Thursday, we'll do the learning activity. You'll be assigned into teams, well, not pairs. You'll be paired up. I'll just warn you, I will be assigning pairs. I think we let you do friends as pairs last time. We will not let you do that this time. We'll spread you around and do more business-like pairs. So you'll be working with someone else in class there. And we'll answer these questions and that sort of stuff. So what we'll do, like we have before, is in class, if you're in class, we'll assign you a partner in class that you can work on there. If you're not in class, we'll assign you or if you're online, we'll assign you a team member. There are questions to answer, and then again, there are instructions there. You do not have to assign, you can just divide and conquer. You can work with your team member in different ways for this. So if you want to just answer half the questions, have your partner answer the other half or something like that, that's fine. You can decide how you want to work on that solution. If you want to just do the whole thing and let your partner just get free credit, that's your personal choice there also. So I don't encourage that. So we'll be doing that on Thursday. Also on Thursday, so we'll do that for about an hour on Thursday. And then the last half an hour, we'll have 2 guest speakers from Grand Rapids who will be talking to us from the county, the Minnesota County Symposium. There's mix or something like that. There's a CIS. Yeah. And so Minnesota County's Information Systems, I think is it. And so we have 2, and that's kind of fun because again, that's a relatively small rural shop there, and we'll talk to them about what they do. And it's interesting to compare that to like Matt, who worked at Apple and works at Target Corporate, which are these, he works with 1,000 developers. And our 2 speakers on Thursday, I think they work in an office with maybe 4 or 5 developers though. So they're, they don't run Scrum teams. They are, that would take up the whole team to do something like that. So we'll talk to them. It's fun. Then we'll talk, there was an assignment on adapter patterns. I've updated the code for here yet. I haven't updated the code for this yet. So I wouldn't start this project yet, or at least not the first part of it, because again, this starting project I haven't updated so that it makes sure it works in our current environments there. So don't start that yet. I know you're just dying to start the assignment. So, okay, so let's go into learning resources. We're just going to basically walk through this same video. I almost re-recorded this video because it is like 6 years old. This is pre-pandemic video, but it is actually still, it uses the first edition of the book, but this chapter is actually basically identical between the first edition of the book and this edition, and all the code is the same. So I'm leaving this video up, and then I'm just recording this class as an option. So things will look a little different here. We have a different version of Visual Studio and a different version of the textbook. But again, all the examples, all the coding, everything is the same. So let's jump into that. So we're going to be going on to chapter 4 of the textbook on, pick up the font a little bit, interfaces and design patterns. And so to start with, we have to remind ourselves what interfaces are for this. So that's what we're going to start with, is just what is an interface here. So an interface is basically, it's kind of like a class, but it's not a class. It is a template for defining classes here. It lists the methods that a class must implement to be that interface or to represent that interface. And so it is just that. It is a separate contract from a class. And then classes will say, I implement this interface for this. Interfaces are defined by the interface keyword here. Rather than saying public class interface, we say public interface here. Now this is a little different than, so that's the main reason here. And then we usually name them with an capital I. So like this would be I, simple interface. So most interface, it doesn't have to be that way, but a common practice is that interfaces all start with a capital I to indicate that those are the interfaces for this. I'm going to open up this code and play with this code while we're doing this. So I'm going to grab this sample code from 2020. And again, this is the same code we're using now. So I'm just grabbing, or, it'll work fine today because this doesn't use any .NET stuff or anything like that. This is just basic C# sort of stuff. I'm just going to clone that repository. And open it up here. Okay, so we can look at that. So this defines a simple interface and most times the interface will just list a number of methods, and it doesn't implement these methods. It just lists the method signature, the start of the method. So like void, if it's returning something, the method name, and then any parameters it has, and then a semicolon. So that's why you see it doesn't implement. There's no code there. It just does a semicolon. It'll list often, maybe 4 or 5 methods that this place has to implement. So if I go over here and look at simple interface, this is what it looks like there. So again, public interface and the name of it. And then here's my methods. And again, a normal interface, I'm going to just delete some of this for now. Oops, I don't want that. Might say, would list maybe a couple interface methods, and again, it often lists what parameters are required for these methods, and stuff like that. But it will not list it. It will not show any code. It just lists the method signatures, the method names, something like this. So often when you open up an interface to go, there's nothing really there, and all it is the list of the methods that have to be implemented for this. Now, this is even more common in Java because in Java, you really can't do much else other than just list methods in your interfaces. But in C# we can do a couple more things. So that's what we're doing here. So in C# we can actually have properties here with getters or setters. Now, again, in Java, in a lot of places, it is frowned upon, and it's kind of an anti-pattern to include data in your interfaces here. But we can list properties here with our interface, and we can also list event handlers here. Again, this makes a little bit more sense because the event handler is a lot like a method, although it is somewhat different in the way it runs. But you can list event handlers there. But again, I would say a lot of this is pretty uncommon here. Most interfaces will just have a set of methods for this. So this is what the book is showing here. Now, okay, you have an interface. How do you say that a class implements that interface? So you have the interface, you have some class, you say public class, the name of the class, and then you say colon, and then the name of the interface for that. And then, so if this interface says that you have some method that has to be implemented, your class then has to implement that method, and then that's where your code is. Your code has to have that. So like here we have this interface here, and if we have another class here that implements that interface, here's our simple class, and it implements, so this colon says it implements this interface here. And then again, we said it has to have a method called this method requires implementation. What a creative name our textbook uses. And so we have to have a class called this method requires implementation here. Now, if we had another class here, so like if we had a class that returned an int, get or let's just call it method two, and it required a string that was a name there. So if we added that to this interface, then here it's going to give us an error. It's going to say simple interface implementation does not implement this member method two, and you have to implement everything that's in the interface. Your quick actions will usually have one to say implement interface, and it will put simple versions of these methods for it here. And right now it's just throwing an exception. And then we would want to go through and write our own code here where we'd, do what we want to that name. So maybe we are checking, if name equals Tom, then we want to return $1,000 salary. Else, everyone else will get a return of a $500 bonus or something like that. So we'd implement that method here. So again, any methods that are defined in your interface have to be implemented in your simple interface, or whatever, your class that implements that interface here. I think this is all Java 2 sort of stuff. This stuff you maybe have seen in Java 2 when you talked about interfaces. Now, do you do interfaces? I think some of you are, or maybe you're not far enough in data structures yet. But I'm guessing you'll do some interfaces in data structures too. You don't have to, but I think Chris will use some interfaces there. We certainly use them a lot here. So another thing to be aware of is that what's nice about interfaces is that a single class can implement multiple interfaces. You might have two interfaces, interface one and interface two here, and then you can have a class that'll implement both of these interfaces. If you've taken our game design class, or if you take our game design class, you'll see something like this at times where we might have a couple interfaces. One, to be able to stick stuff in our inventory to display it on the screen. So we might have like an eye inventory interface there. We might also have like an eye damage interface or an eye weapon interface so that if you have an object that can cause damage, we can call that, and we can know that we can call your method and say get damage or that sort of stuff. And so a single, like a sword object or a weapon object might implement both the eye weapon interface, eye damage interface and the eye inventory interface. So it can be both stored in inventory and we can use it to do damage there. So it's quite common for a class to implement multiple, 2, 3, 4 interfaces sometimes, because we'll tend to create smaller interfaces in a lot of patterns that just have one or two methods associated with them for that. And again, if a class implements multiple interfaces, we just have to make sure it implements each of the classes in that interface here. So again, if interface one requires this method one, we have to do that. And if interface two requires method two, we have to implement that also because we're implementing both interfaces. Now, this is better than what we call multiple inheritance, because again, there's some, as far as functionality, some overlap between inheritance, making one object a child of another object, and interfacing, making one object implement an interface in that how you can pass things around and some of the problems it solves. But we have some problems. In general, we do not allow a class to implement multiple or do multiple inheritance. So you can't have a class that implements two different parent classes here. You can have it as far as interfaces go, but this is just showing that there's a problem with inheritance. So it's child classes rather than interfaces. So that's why we'll tend to use, and again, in a lot of places, I think 20, 30 years ago, we did inheritance a lot because it solved some problems. And we did not really have interfaces. But interfaces have really taken away a lot of the reasons for using child classes or using inheritance. There are still some good places to do inheritance, but a lot of those places have been replaced with interfaces these days. So there's a bunch of this chapter that we're just going to skip over because it's not that important. But if you want to read it, that's just fine. So all this stuff in highlighted in golden or yellow here. So explicit implementations really are not used that much the way we do that. So I'm not going to talk about explicit implementations here and how they work. If you ever have to do that, you're going to have to research those. But again, I don't know any place that really is doing that sort of stuff. Yeah. So we're going to skip over all this stuff on those. And again, they walk through the same kind of methods, the same sort of examples, but with explicit interfaces here. Polymorphism, this is what we were just talking about, is an object of one type can act as an object of a different type. And this is where we see this a lot in interfaces a lot there. You might have, like in this example, we have a car, a motorcycle, and a speedboat type classes. So maybe we're running a repair shop or something like that. And so we create objects of type car. Whenever a car comes in, we create an object in our database or our system for that. Or maybe have different types of cars, motorcycles, and speedboats. We have lots of objects of these types here. We have slightly different attributes and methods for each one, although there's some shared stuff between them. But there are times where we want to create a list of like all the vehicles in our repair shop or something like that. How do you create a list of objects of different types? There's no way in most languages to create a list of objects of different types unless they all have the same parent or implement the same interface. And that's what we do. We'll say all these objects implement the same interface, in this case, the I vehicle interface, and they have a set of shared methods. And so we can then create a list, an array, or something like that of I vehicles here. And so we create an array of I vehicles, and then we can put a car in there because a car can pretend to be a vehicle. Because it implements the iVehicle interface, or a motorcycle or speedboat. All those things can be in this this array of objects for this. Or if we want to pass an object to a method, and we want it to be able to take either a car or a motorcycle or speedboat, we can say we're going to pass in a object of type iVehicle to this method. And then we can pass in any of these. So polymorphism, that's what it means, is that we can have one type of object have implicit act as a different type or act as a shared type of this for this. So we can have all these types pretend to be a generic type, an iVehicle type, for example. Another example here is uh from like Amazon here. You can imagine how the Amazon, or we were just talking to Matt, how the Target website works. Let's look with Target. So Target has their website. You can add items to the cart. You can be billed for these items there or charge for these items. So if you're creating a bill or a checkout cart, you'll want to be able to add all sorts of items to that. So you might have a book class here. You might have an electronics class. You might have lots of different classes for your different objects that you sell in your store. But you want them all to be able to show up on your checkout cart or be billable. So a book will implement the a billable items interface, I billable items. And all we're just saying is a book is a billable item. It implements the I billable item. So an I billable items. And what do we have to display when we do on the checkout cart or something like that? We have to display maybe the item description. We have to get the cost of the item, and then we have to get the shipping weight so we can add up all the shipping weights. Is there anything else we need when we're printing off the bill? When you check out at Target or at Amazon, what else is on that? So I mean, you'd put all that in what are the methods you need to do to print off the bill, and you make that billable item. And then you're just going to make sure that books and electronics and sporting goods and food, all these things implement the same interface. So, I mean, they'll have other things. Books have titles and authors and all this stuff. But they'll have a print description method. So we can print that. We can return a string for display on the bill. They'll have a get cost method here. And guess cost is returning a decimal. I don't think we've talked about decimals yet. You're probably still using doubles for currency. I mean, that's what we teach. I mean, I taught that yesterday in Java 1. When you're storing some currency, you're using like a double or or a float. We're not doing that anymore. That's Java 1 stuff. So most languages have a class just set up for like currency things and simple decimals. So it's usually a decimal class. It just gives us a little more accuracy with the digits than a floating point number would here. So just so you know, you'll see that now. I'll be often switching and you go, what is a decimal class? And just know that's just the class Java has decimal. Does anyone know if Java has decimal? I assume, great. Java has decimal, doesn't it? Yeah, it has float. I mean, so does C#, but I think it should have a decimal class too. Someone look that up and let me know. But certainly C# has decimal, and we'll be using that. So again, I got sidetracked. Okay, so our interface, iBillable item is implementing a get cost. Java has decimal too? Okay, yeah. So just so you know, when you get out in the real world, you should be using decimal, not float for things like that. Here we're actually implementing a property because it can, so we're just doing that. And so again, we have to have a property there. And it might be tied, our property might be tied to some internal representation, obviously, of that there. So again, that's an example of a billable item. And again, you would have a lot of different types of objects in your store. And again, because with a book, you'd have a title and an ISBN number, stuff like that. And for your food item, you'd have your expiration date, or use by date and stuff like that, where a book doesn't have a use by date. So you'd have different fields or attributes in these different areas, but they'd all share the billable interface. And so that means they'd all have these set methods. So we can call them back and forth. Okay. We're going to start talking about design patterns. So design patterns are common frameworks for setting up code. and using code and stuff like that. And you probably in your head have some kind of like design patterns that you've seen, like I was just talking, we were talking loops in the Java 1 class, in a standard loop format for like displaying a menu, asking the user for the input, and if the user says something, you exit the loop. What we call a input controlled or user controlled loop there. And there's kind of a standard pattern for that. You use a do loop, you display the menu of items. One of the items is to quit the loop. You have your if-then statement or your switch statement based on what the user said. You do, and you keep looping up and do it again. And then you do while. The while is until the user selects the item that means quit from the loop. So it's kind of standard way of setting up loops like that. And if you're in data structures, again, there'll be standard kind of patterns for how you handle lists, linked lists, doubly linked lists, and trees and stuff like that. So we'll be looking at some other kind of patterns, more complicated, or I don't know if they're more complicated, just different types of patterns that use like interfaces and stuff like this. These have been around since the mid-90s, so a lot. If in your mind, it's been a long time there. I certainly remember when before we had interfaces or patterns or anything like that. So we'll be looking at the adaptive, so some different patterns. And again, the reason for these, and they're calling these adaptive patterns, and this whole book is called Adaptive Code, is we want code that can be used easily and modified easily and grow easily with our example here. So we want to set up our code for doing that. Okay, I'm going to have a little sidetrack here. So because of adaptive patterns that remind me. So did I post the link here? I think I tried to create the link. Oh, I don't have it up yet, I don't think. So I don't know if you've heard, Google has this this notebook LM stuff that you can do. And it lets you load in a whole bunch of documents and then create note or ask questions. This creates basically your whole AI or AI focused just on your document. So I was testing out and made one for our whole class. I'm going to play with it more. So I just loaded our whole textbook. I think I may have slightly bent copyright rules by putting the entire textbook in here, and our syllabus, and I'm starting to bring in each unit into here there. And then you can ask any questions about it, but you can also have it create podcasts about this. And so I'm having it create podcasts about our class. I'm still not really used to this interface. So let's see, where's our
It was really cool stuff to work with. Professor Gibbons' software design syllabus and get this excerpts from adaptive code itself. It's like having the answers and be the teacher's notes.
Yeah, it's a really cool comic. See, the syllabus lays it all out, like a roadmap of what a student needs to know. Things like taking out a lot.
Okay, jump again.
What you need now, but later on.
Yeah, okay, that.
Yeah, except in code, you pay back with complexity, with potential bugs down the line.
Gotcha, so it's a trade-off.
Exactly.
Sometimes you gotta move fast.
Exactly. And adaptive code gives you the tools to manage that debt, so to speak. It goes really deep on things like interfaces, which are like contracts between different parts of your code.
With contracts, like a legal agreement, right?
In a way, interfaces make your code way more.
So does that sound exciting? You say, I want to listen to that whole podcast now, right? So I will try to post a link to that podcast here. So and that's just basically on you. Well, outside. I just think it's hilarious. Sorry. Okay. back to our example here. So again, we're going to be looking at lots of design patterns. The first one we're going to look at is the null object pattern here. And the idea here is that it's sometimes hard to handle null objects for this and to be able to check. So often we want to go and get a customer from our list of customers or get a product from our list of products there. But we search for the product ID or the product name or the customer ID and we don't find it. Someone maybe entered something wrong, their name wrong or something like that. And so we come back, how do we handle that when we don't, how do we return that? Often we just return a null pointer, and null pointers can get us into lots of trouble in code there. So generally we don't try to return a null pointer. We return what's often called a null object, maybe an object that doesn't have any data in it or stuff like that. And again, you've probably all run code where you've done some sort of search or some look, you called some method supposed to get some object and it returns nothing. And then your code crashes because then you try to reference some attribute in that object and that attribute doesn't exist because that object doesn't exist here. So this talks about a way of handling this null reference stuff with a null object. Here. And so on Thursday, the learning activity focuses on implementing. We'll look at this exact stuff. So the idea is that go back here and look at so this is the code from the example here. And the idea is that we have a user and we'll be trying to get that user or use that user. We'll have methods that'll return a user, like find user or something like that. But if it doesn't return that user, we will then create a null user. So we'll have a separate object called null user there, which will have like an empty name or the name will be unknown or something like that. And we'll implement the methods we want there. And so both of those, both the user and the null user will implement this iUser interface. So both of them implement this generic interface, which we'll see. Where's my interface? Here's my iUser interface. And again, wait, maybe they'll have a get name method and increment session tickets. I think this is like for a help desk thing or something like that. So we'll have one method and then a get name that anytime we're using a user, a user has to be able to do those things. And then null user and a general user will both implement those. So this is the idea here from the textbook that we show our client. Rather than accessing the real object, the user object, the client will interface, go through this interface, in this case, an iUser interface. And then you might end up with a null object or a user object, but you don't, as a client, you don't really care. You can treat them, they're both objects kind of the same way for this here. So again, they walk you through this code. This is they're creating a repository of users for this, getting users by ID for this. We'll actually see this when we'll return to our student model view controller website, and we'll see this sort of, we have a user repository there also. And again, the problem is that when we call like user repository get by ID and we specify user ID, we'll get a user. And we'll often have to check if that user is not null. And if it's not null, then we can access that user stuff. Because if we just try to access that user stuff without checking, our method will crash when that user is not found. So we have to check if that user is found first before we call a method for that user. So we have to do it this way. If user does not equal null, then implement this. And some code, I mean, this might not look that bad, but some code, these users null checks get incredibly complicated. Here's a old null user sample. This is code, old code of mine. You used to be able to go to Amazon and query the Amazon API for any object out there and just I once wrote a script that would just download and create a database of every object, every book for sale on Amazon there through their API here. But in order to do this, Amazon gives you a list of arrays and stuff, and there's lots of checks in here. This whole thing is almost all checks. If not list array is nothing. Again, this is a different in Visual Basic. And then once we find out that the list is there, then we have to check if not the list is nothing. And then once we do that, we have another check with the array inside of that. And then another check and another check here and another check here. So again, just in that set of code, I think we had 6 checks for null objects here. And there's another check above it, 2 other checks above that for this. So again, sometimes this code, it just overflows with checking if an object is null in some way or another. So, so instead of doing that, we are going to implement this pattern here. So we're not going to just have our client implement get users. We're going to implement the iUser pattern, and then we might just see a null object. And so we do not have to do this check necessarily here. So again, here we're creating a list. Our user repository has a list of users. Oh, this is doing. Let's go down here. Now we have our null user implements the iUser pattern here, and so we can implement it that way. And set things up, because what they're really talking about is this: you can do lots of checks if something is null. Like first you want to see if you're getting a person, if the person is null, and if the person is null, then you're going to look in the person's details and see if that's null. And if that's not null, if that's there, then you're going to go in their details and get their age and make sure it's some value. So you have to do all these checks just to get the age, these null checks for this. And so this talks about this is null or returning null or this sort of stuff is kind of an anti-pattern. We want to get away from just returning null objects in some ways with nulls. So we'll look at this. We'll implement a version of this pattern in the learning activities and talk a little bit more about it here. But the idea is just to create an object that is a null version of the object, so that then you can let your code just process it, even if the user is not found, and you don't have to do that. The next pattern is the adapter pattern. And this is what you'll be looking at in your assignment this week, is the adapter pattern. Now, there's 2 ways to implement the adapter pattern. One is with classes, and we're not going to talk about that or do that. So I'm going to skip over this whole class example of it. And again, if you look online or ask AI, make sure you ask it. We want to do it with interfaces here, not with classes. So sometimes you'll see examples of this. We don't want to implement the adapter pattern with classes. We want to implement it with an interface. So why do you need an adapter pattern? So let's say you are trying to implement an object, or you're trying to you're kind of updating your code, and you want all your classes to implement or use this interface. And most of your objects already implement that interface, but some of them might be old, or you can't access the code, or they're for some reason you can't really change them there. And so you can't make them implement the interface directly here. And so what you do is you create an adapter that will let that object implement this interface that you're trying to do. I'm going to jump here and bring up this example here. So again, this is talking like similar to game, like in game design. Let's say you had your game was managing a bunch of enemies that are around or doing things in your game there. And so you're treating different objects as enemies here, and you have an interface called the enemy, and one thing that what enemies can do is attack there. So you have all enemies have to provide an attack class, so that if you have an array of enemies around, you can just say, you can go through that list and say attack, 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 and have every enemy attack there in whatever way they think they can. But maybe you have some special enemy there that doesn't have an attack class or a method. It doesn't know how to attack. Maybe it only knows how to cast a spell there. So it has a method called cast spell. Now, maybe you could go in and change that class, that special enemy, so that it had an attack method. But there are times where you can't modify that. So sometimes it's maybe in some old legacy code that you can't modify. Sometimes you're accessing it through some special API or something where you can't control it. Sometimes it's controlled by a separate client or a separate someone outside your organization, and you're doing. So there are times where you can't just go in and modify this code here. So we can't change it. We can't add an attack to special enemy here. So instead we add an adapter here. We create a new class that implements this interface here and has an attack method for this. So like our special enemy, its only class is to cast a spell here. But our interface, it wants a method called attack. So what we do is we create an enemy adapter here that implements the enemy adapt. It implements the attack method. Inside the attack method, it calls the get spell for the special enemy. So it kind of converts the attack method to a get spell method for this special enemy here. It creates an adapter for that stuff. And then in our main program, again, we might have an array of enemies or whatever, and then we can just call them all, tell them all to attack. And again, what I think of here is, I don't know if you ever traveled internationally or some other places, but one thing you notice is that different countries have whole different plugs for electricity in the walls there. United States has two vertical lines. If you look at and then a ground below it, that's a circular kind of stuff. That's not all that common in the world there. A lot of them will have like just two round poles. They'll be, Ireland has these huge plugs with three square or rectangular things, so different places. So what we sell is when you travel is you have these adapters that will plug in to one socket and then let you plug in your socket into that there. You also have to watch because there's some different voltages involved, and so, but a lot of things these days will run on the different voltage. You just have to get it connected there. So you'll find some sort of adapter. So like when I'm traveling, like if you're going to Europe or someplace or China, again, you've got this collection of the different adapters, and you show up at the hotel and you say, oh, which one of these adapters is going to work to charge my phone up. So And so that's what it is. It's converting something which you can't change into something that you need, some interface that you want. So again, the book shows is that we have some interface that are, like our phone. So plug into this interface. We have an adapter that connects up to the old method, and the adapter then will convert our thing to work with this, to work with the older or the set target in object out there. So, so they work through an example. I'm not in love with their example, and so we'll look at a couple different examples. And again, on your assignment, we'll deal more with that. So we'll deal with a sample code here and walk through that. And then we'll have you answer some questions about this pattern here. Because I didn't love the example in the book, there's a couple other examples out here. I gave the indie dev art example with the enemy and the attack pattern. I like that. Tutor's Point has another example here with media players there. So if you have different media player out there and you have you want to be able to play some media here, you might play it. They talk about setting this up and working through this media player example. I think that is not bad here. Another thing you could consider if you want to see some is just here. I'll include some standard AI prompts for this. So like explain the adapter pattern using C# example that illustrates the importance of interfaces. So that'll make sure you get the interface example of it and in C#. So if you place that prompt into most AIs, I've only checked 2 AIs, but both of them came up with pretty nice examples. And they were correct. This is the type of stuff where you'll generally get you won't get as hallucinations very much because there's not a whole lot to hallucinate about. It just explains this pretty well. Okay, so that was the adapter pattern here. Another pattern is the strategy pattern here. And so the adapter pattern adapts some object we can't modify and lets us bring it into our code here. The strategy pattern will allow us to call or work with multiple different objects and use be able to run multiple different objects in this sort of way. This is kind of a standard way of using interfaces here. So again, maybe we want to have 2 different objects or ways of handling some situation to execute some code, generate a bill, something like that. And so you might want, let's say we're printing out our cart or creating a bill for a hospital here. Depending on maybe their insurance or something like that, some other things, you might have one strategy for printing out the bill or billing the customers, and then you might have another way of billing them. So you might have an execute method in both. You'd have an iStrategy interface with that execute method so that your client can just say, execute, call the execute method, and it would, depending on either of these objects, could, however you instantiated that object, it could satisfy this interface for you. And it walks through the code for this. So again, we have an interface called iStrategy, and it has just a method called execute. And then we have 2 classes. Again, in the examples of the code I actually like, they often have this all in one file. You just got to remember that, this would be one file and it would be much more complicated than this. This would be in another file. And this class will be in another file. So each of these classes would generally be in a different file. So here's our interface. Here's our concrete strategy A, and it implements that interface. So it has its own execute method. Concrete strategy B implements I strategy, so it has its own execute method. So both of these have implement a different execute method here. And in our public class, we might have some check where, depending on, we're going to just execute. We have some object that we've instantiated with either strategy A or one of these objects, and then we're just going to say execute to execute that strategy for that. I don't love this generic example that much. So I do have another example of it here. It's two there. Okay. So here we have, again, they're talking about robots here, but you could also talk about non-player characters in a game or something like that. So I pull a lot of examples from games because I figured sometimes you probably know more about playing games and game software than billing software or customer management software, stuff like that, because you may not have seen as much or paid as much attention to that. Where this would be. So here we'd have iBehavior method, and we'd have like a move command there. And we're going to tell our robot or our non-player character to move, and we'll have different strategies. So maybe we have an aggressive behavior, a defensive behavior, and a normal behavior. So we could tell our robots to move that way. You can imagine the same thing for our non-player characters. There, they all implement iBehavior, what only means they all have a move command. When we say implement iBehavior only has one class in it, the move command. So they all have a move command, and they'll move in different ways depending on the strategy. So defensive behavior will move, and maybe run away from you, and aggressive behavior maybe will go towards you there. And so then we have our robot class. And again, maybe we're doing some check here, and then we're calling, we're maybe creating different behaviors for this. And then we are, the command here, we will actually run one behavior or the other for this object based on its current position. So maybe, again, and you've seen this if we're moving around here, if you are here and your robot's close here, you might have it react aggressively. If the robot's far away, you might have it go defensively. So you might check and change the behavior depending on how close you are physically to so each of these objects can see, and you can kind of see these circles here defining maybe the aggressiveness. So if you're not within this circle, it won't behave aggressively towards you. But once you get within that circle like these, it will behave aggressively towards you. So it's just a way of implementing that sort of idea here. So again, in our main, we instantiate different behaviors. They're all iBehavior objects, so they all can be treated the same way. And then we can just swap basically one for another, because since they all implement the same interface, we can actually treat them all as basically the same type of object. So again, I kind of like that example. You can read more about that. That's this final example here in this little box for this one. Okay, so the strategy pattern. We're not going to do the strategy pattern in any of the assignments. I don't think I even have a question about it, unfortunately. Okay. There are other stuff here that we are just going to skip over. Feel free to read through duck typing if you want. Dynamic language stuff. Yeah, impromptu interfaces, all this stuff. There are languages, particularly like scripting languages, sometimes like JavaScript or Python, where you do not require them to declare everything as explicitly there. So you can just say, this is a variable, and we're not going to tell you what type it is, what type of object is it. But when it calls a method, then we'll try to figure out what type it is. Or when you assign it to something, then we'll figure out what type it is. Then we'll try to figure out how to use it there. And so there's a whole area of like how you trying to work with this, you know, trying to figure out if this object if it looks like a duck, is it a duck, and can you use it there for that. So again, we're not really going to get into that. One of the reasons is that you really shouldn't be using it. I don't know if you remember when Matt was here, he did a lot of JavaScript. I mean, his whole website was in JavaScript, but it wasn't in JavaScript, was it? What language was he using? TypeScript, right? And what is TypeScript? TypeScript is a strong typed version of JavaScript. All it is JavaScript with types, because loose types, old duck type stuff gets you into so much trouble there. So almost everyone in the real world, I think, who's using JavaScript is not using JavaScript. They're using TypeScript to force you away from generic variables. And again, sometimes even in C# here, you'll see examples where it just says var, not a type, var, and then declares some variable and doesn't declare what type it is. I will try to never do that, but again, it's available in some places. We will just try to avoid that because again, I've never been in a code inspection or submitted code and walk through code with the other developers and come to something like that and had someone say, "Oh yeah, that's okay." It's always no, you've got to explicitly type that. So all this stuff we're going to skip over on this until the very bottom. We're going to get to fluent interfaces here. And so let's just talk about what fluent interfaces are. This is sometimes called method chaining here. So it's kind of might seem strange, but what you can do is you can have objects return the same object back. So if you're telling an object to do something, it will return itself rather than like a string part of them or something like that. It will return the whole object back. So why would you want to call an object's method that also returns that same object? And again, you can do it with interfaces also, where you can have require an interface that returns that whole interface. So what we see here is without fluid interfaces or this sort of stuff, if we're calling a whole bunch of objects or methods, we have to say, we have some object here called fluent here. We've created a new object called fluent, and we have to call a bunch of methods, fluent.do something, and fluent.do something else, and fluent.do something else, and then fluent.do something, and fluent, this method is not fluent. We have to add this stuff. We call these all on separate lines. But we're really lazy developers and we don't want to return. We have to have fluent every time here. So instead, we chain these together. We'll say fluent.do something, .do something else, .do something else. And this has it all on separate lines, but it is more common. Let me just grab and put this somewhere over here. I'm just gonna grab this whole class. So I'm not getting. Control C doesn't work in some places like this electronic textbook here. So rather than having this all here, we can call Fluent, we can call and that's why we call it method chaining. We can chain these method calls together for this. And so sometimes you'll see this sort of stuff where you say some object dot do something else dot do something else here, and you'll see these all chained together in one long call. And again, this only works if each of these methods returns the same object back, or maybe sometimes it returns a sub-object and you have to do things a little differently. But again, the idea is that you might have this. I like a typical example I see is like when you're working with images and you have a bunch of image processing routines. So you'd say, you'd have like an image and you'd have a you know, update focus. And you'd have another method for also, you know, and you want to despeckle the image, and you'd have another method for update contrast. And you'd have another one for deblurring here. So and you'd have a bunch of things. So maybe you'd do some blurring, and then you'd do despeckling, an update content, unblur, and stuff like that. So again, you'd chain these methods together. And again, they work because when you call update contrast or deblur, it will return, it'll do that action and return an image there. So if this is an image here, you call a series of methods that each return that image or an updated version of that image, but something of that same type, that image type for that. And so that's what they're trying to get at. And I think, I mean, I've certainly seen examples of that in lots of code where, again, it's more common, it seems like, in some libraries of stuff than other libraries of stuff, where the whole library is set up in kind of this fluent way where you can chain these stuff together. And again, it can be done just with objects, but you can also set up interfaces and put an interface over this so that it will, you force everything to work that way. So every method returns the object also. So again, they're doing this where you say do something, it returns the interface object here, and do something else returns the interface object. So everything will always return an interface object. So everything that implements iFluid interface also returns an object of type iFluid interface. So then you can chain these together. So there are whole libraries that are set up that way with that. So just be familiar with that as a common pattern out there. So. Okay, so that's, I think, everything we need to cover today. Again, now I often suggest, again, that I think it's helpful if you wait and read the book after I go over it here. So I think now if you go over and read chapter 4 of the textbook, and hopefully, and again, I will tend to go over and not cover everything, assuming that you're going to go through and read it. But I think it helps if I kind of set this framework, tell you what parts we're going to skip, and then you can go out and read the textbook, read through that. So certainly suggest you do that here. Again, we'll do the null objects in class on Thursday, and our guest speakers I don't think I have our guest speak, oh, here. Yeah, our overview. So Julie and Trish, Trish is a 2018 graduate. Julie is a 2020 grad. Again, they're at the Minnesota County Information Systems in Grand Rapids, and so we were talking to them on Thursday. And we'll jump. Hopefully, we'll talk to them about 11 o'clock on Thursday. So. All right. Any questions on this? All right, let's wrap up for the day.